Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 16th. First up, we'll take a look at significant wave heights for the North Pacific Ocean. Currently, a small area north of Hawaii, 20-foot seas, and another just west of the dateline, 20-foot seas, all symptomatic of broad low pressure centered roughly in the Bering Sea, circulating across the North Pacific Ocean, but nothing of any significant size is indicated. Let's take a look at jet stream level winds. These help support the formation of storms and also direct their path when they do form. Currently, there's a good healthy flow coming off Japan, centered fairly well to the south, 35 north, with winds in the 120 knot range, pushing about 150 here over the dateline, falling into a trough. It is in this trough that one would expect to see gale formation. That is, it would support the formation of counterclockwise winds in the upper levels of the atmosphere, which would manifest themselves down at the surface as low pressure. Currently, a little bit of a trough here off the U.S. West Coast, north of Hawaii. It's actually been here for quite a while, semi-permanent trough, and a bit of a ridge here that supports high pressure off the U.S. West Coast, but it appears to be breaking down a little bit. Let's put this into motion and see what happens. Roll this out, we're into Monday, and notice a new batch of energy is supposed to develop off of Japan, pushing towards the dateline into Tuesday. Good healthy winds here, again about 180 knot winds, and you almost think there's a bit of a trough trying to form here, but it doesn't. It turns into a rather flat flow. But here's the interesting part. Notice the ridge that's been off the U.S. West Coast starts breaking down, and a good healthy flow starts rolling into Northern California. We'll roll this out some more. It even develops more. There's no split in the jet by Thursday, supposedly, and the jet basically comes barreling right into Oregon with a bit of a trough pushing down into California. This continues with good healthy energy moving into the Gulf of Alaska late Friday, about, 160 knot winds or so, pushing right into Northern California. A bit of a weak trough here, but for the most part it's a zonal flow, flat west to east. And that continues. We'll just roll this out, pushing into Oregon, and then a bit of a ridge starts developing again here off of California. And again, this kind of weak trough thing north of Hawaii, but nothing really supportive of gale development. And that continues into 180 hours out. So perhaps this will usher in some weather for California for a bit, but by late Sunday it looks like high pressure is going to start building underneath the jet here and sort of put a damper on that. And there's no big troughs indicated and not a whole lot of wind falling into even the meager troughs that are forecast. So that suggests not particularly a lot of good support for storm development down at the surface. Let's go look at the surface level charts. So here we go, surface level pressure, surface level winds, little bit of low pressure here northeast of Hawaii. What is that, about 1,000 millibars? That's certainly not enough to support development of storm formation, not even a gale. And then a couple of patches here of random 30, 35 knot winds. That's good for 12 to 13 second period swell if it has some duration. Put this into motion. A little gale tries to wrap up here Monday, and this system tries to build a little bit more off of California on Monday as well, but no real winds of interest. Here we go. Then we get into Monday night, 35 knot winds off of Central California, and low pressure here. This is sort of what we saw earlier, just this continuous fetch, sort of 20, 25 knot fetch across the whole North Pacific Ocean with just embedded pockets of 35 knot winds, but nothing significant. Here we go, low pressure developing more on Tuesday off California, but then lifting north up towards Vancouver Island. A stronger gale tries to organize here northwest of Hawaii or just east of the dateline. 40 knot winds, but notice the wind vectors all pushing more up towards Alaska than anything towards the U.S. West Coast, and certainly not towards Hawaii. Roll this out some more. Oops, we got one little shot there of 45 knot winds, but again, aimed to the north, and this was as of Wednesday night. We put it into motion, broad fetch of 30, 35 knot winds, but just doesn't really get organized here. I mean, this covers a large area. That's impressive, and just like what we talked about in the opening here, low pressure, this has been the pattern. Low pressure up here, Consistent fetch, but just not strong. Broad, but not a lot of power. Now here we go. We're 126 hours out into Friday night. A broad area of 30 to embedded 35 knot winds. That's good for, again, 12, 13 second period swell. And it continues on into almost Sunday and then starts petering out again. And here's the high pressure that builds off the U.S. West Coast. And then it looks like things sort of fall apart again, and that's it. So not a whole lot to see even at the surface. Just for laughs, let's take a look at precipitation, since that is of concern for the U.S. West Coast. Put this into motion. Here's the low pressure system we saw Sunday night developing. Get a pretty good area of rain, but none of it makes the coast before the low actually starts to fall apart. Some of it starts bleeding in by Tuesday night, and a little bit of snow in the mountains here, but not looking anywhere near as powerful as it was a couple of days ago on the charts. Another little low sort of tries to develop, pushing a little front here and more precipitation into late Thursday, and there you go. We're into Thursday night, snow in the mountains, a little bit of light rain into the coast, and that quickly fades out. And then one more shot. This looks really good for up in the Whistler area and Pacific Northwest, but not so much for California. A little bit, maybe a couple inches of snow, and some more rain again into Saturday. So that's three small rain events, and mainly isolated from Monterey Bay northward, and then here comes your high pressure, and that's pretty much the end of it. So finally, let's take a look and see what happens down at the ocean surface in terms of sea production. Again, current view, 20-foot seas north of Hawaii, another patch just west of the date line. Not a whole lot of real interest. And then here we go, the new low forming off of California, another low up here in the northwestern Gulf. That's 26-foot seas, but actually, let's put this back. We actually got a little bit of 30-foot seas, but it looks like it's more pushing north than anything. Relative to Hawaii, it's on the, hard to see here, it looks like about the 330 degree, that's 345 degree path. And actually probably better aimed at California down the 302 path, but a long ways away and not holding together long at all. We get another local area, 20-foot seas off of California relative to Northern California. That's the what is that? The 273 degree path. Southern California might see more from this, 287 degrees. Actually, let's put it back. Yep, 287. We'll roll that in. That's about as far as it goes, and then it too starts fading out. And then here we go, another little broader area relative to Hawaii. What is that? The 342 or so degree path. Probably better relative to Northern California on about the 296 degree path. So, I mean, good for some degree of limited swell. 26-foot seas then into Sunday. Again, that's much more Northern California oriented in the Pacific Northwest, but relatively north, like above 302 degrees, almost 308 degrees. Roll this out some more, and then there's that broad fetch we saw. Here you go. Here's 18 to 20-foot seas. 20-foot seas, 22-foot seas. There we go. Maybe a little bit of 24-foot seas. This is 156 hours out, though, or on Saturday night. Relative to Hawaii, then we're looking about the 331 to 338 degree path into Hawaii. And for Northern California, yeah, about the 296 to 300 degree path or so, and more so for even higher for Southern California. Roll that out, and there you go. Then it's all over. So the short of it looks like 13-second period swell, rather small in size relative to the East Coast, a little bit more, the West Coast, a little bit more size for Hawaii, but not directed very well to the islands at all. So sort of more of the same, just rideable surf, but nothing great. Next, let's take a look. Southern Oscillation Index. Difference in pressure between Darwin, Australia and Tahiti. Negative numbers represent the active phase of the MJO. Prolonged negative numbers potentially represent the formation of El Nino. Current numbers, daily average, or daily index, minus 7.26. 30-day average, holding quite well, minus 10.88. And the 90-day running average, minus 8.33. We'll go back and look at the entire month. minus 7.37. It dipped down to about, oh, here's about as deep as it got, about minus 8.8, and it's still hanging in that range. Sort of borderline minimal El Nino conditions. Not bad. This all represents generally a weak, continual, long-term simmering active phase of the MJO. Next, we take a look at 850 millibar wind deviations from normal for this time of year. What we want to see is westerly anomalies. This is the Kelvin wave generation area, bound a couple of degrees either side of the equator or north of Australia, 140 east to about 170 west. Put a box in it here. You want to see these arrows going in the opposite direction they're going in. This suggests that the inactive phase of the MJO is in control right now. So the MJO, we've not really talked about it much, but is a oscillation in the atmosphere. It basically goes 3 to 4 weeks active, 3 to 4 weeks inactive. We're in the inactive phase. The interesting part is that if we were in fact in El Nino, typically what happens is the MJO disappears, or if anything, it turns kind of just perpetually weakly active. And what you'd want to see is westerly anomalies, not easterly anomalies. Westerly anomalies help create Kelvin waves, and that's what pushes warm water to the east, and that's what gives you that's the hallmark of El Nino. This is the first time we've actually seen easterly anomalies almost all year, and this is a little bit surprising and maybe a little bit concerning too. Not so much. I mean, all the warm water that's going to get transported east for the most part for this year, and normally El Niños peak in about the mid-December time frame. That warm water is already in the pipe. What we're wanting to see is a continuation of westerly anomalies, and hopefully to feed this into a multi-year event. This does not look to be supporting that cause because, one, the winds are blowing the wrong direction. Two, the fact that they're blowing east at all suggests that no more Kelvin waves will be created, at least for a little bit, and that maybe this multi-year El Nino thing that we were hoping would develop maybe would not develop. Anyway, let's continue on. Looking to the over the date line to the west, here's westerly anomalies, but they're too far to the east. We really need them on the other side of the date line. A week out, back to neutral anomalies. That's a really good thing. A little bit of easterly anomalies can be tolerated. A lot of them would not. So supposedly a week out, neutral anomalies in the West Pacific, and in the East Pacific, again, a little bit of these westerly anomalies on the equator, but not a whole lot. Here's the trend. The oranges and the yellows are westerly anomalies. The blues are easterly anomalies. This was one little pocket we had in early November of easterly anomalies, but there's been a lot of westerly anomalies, just persistent in this area. Here we go, from about here to here is where you want to see it. So that'd be from here to here on this chart, and we're looking at time here. So there was a westerly wind burst in October, and then little bits and pieces, not east, not west, and then a little easterly anomaly. Here's the forecast. A pretty decent easterly anomaly event starting right about now and going for the next week or so. And again, it's this area from here to here. So part of that is in this area, but not all of it. Next, we take a look at outgoing long-wave radiation. Oranges and yellows suggest more reflectivity, that's sun reflectivity off the ocean surface, meaning less clouds, meaning the inactive phase of the MJO, meaning easterly winds. And sure enough, that's exactly what we're seeing. We see easterly winds on the chart, and the models are in fact suggesting that we are in an inactive phase. The good news is it's supposed to last for about a week and then start dying out. And per this, the statistical model, a active event, the blues, less reflectivity, more clouds, and westerly anomalies are supposed to be starting to move into the West Pacific about 2 weeks out per this model. The dynamic model is less favorable in that it doesn't show the active phase migrating east. It dissipates in the Indian Ocean. But the good news is the inactive phase is supposed to fade out 2 weeks out. So we'll see. The interesting part is the models have shown this in the past and it never materializes. So the question is, are the models right? Are they overhyping the inactive phase? And will it in fact fade out and be a non-event like all those before it? And again, those were all models of what's to happen. This is the ground truth reality, the TAO buoy array. Buoys strung across the equator from east to west, and you can't actually see the buoy positions here, but when you these arrows are based on data from where the buoys are at, and you can just see them lined up here, and they are also depicting easterly anomalies. So there is some sort of an easterly anomaly event occurring now, which is not particularly good news. And finally, the ultra long-term model, the Jetstream level 40-day model. Here is our supposed inactive phase event right now, currently about over the date line. Here's the West Pacific, here's the East Pacific, the equator is right here. The oranges and yellows are areas less supportive of precipitation, which we would interpret as the inactive phase of the MJO and also easterly anomalies. So here's one wave. This would be the inactive phase of the MJO, and pretty normal looking actually if we were not in some sort of an El Nino year. So that would go and exit out of the East Pacifico by about the first week in December. Here comes the active phase right behind it. It would start in the west, migrate east, starting about the beginning of December and last into about the December, right around Christmas time or so, and then another inactive phase behind that starting the 21st of December. Whether to believe this model or not, who knows? It's a 40-day model. Sometimes you can't even trust the 4-day models, but it gives you a rough guide of what's going on. All right, sea surface temperature anomalies. This is water temperature anomalies. If you want to see El Nino, you want to see warmer than normal water starting in this area, but officially bound in from this area right here where I'm drawing the box, the Nino 3.4 region. And certainly we see that. Looks like about, half to maybe 1 degree anomalies with warmer water back over the Galapagos. This is actually the best the signal has looked for quite a few months, suggestive of some sort of a very weak El Nino event, maybe, I don't know, 0.7 or 0.8 degrees above normal. Certainly a weak El Nino event, if anything at all. Modoki El Nino would probably be what we call it. That is, an El Nino that's sort of an El Nino, but not really an El Nino. Also notice all the warm water, I mean, the whole way up the U.S. West Coast, down into Peru. Other than this one little patch here of cooler than normal water, everything's warm. All this cool water here is really the result of tropical systems tracking off of Japan, tracking across the North Pacific. They stir up the ocean surface, create some upwelling, and that cools temperatures down. But even now that the tropical track has sort of simmered down, you notice that some warm water is starting to build back in here. Likewise, you got the same situation going on over in the Atlantic as well. And for that matter, over in the Indian Ocean. So there's a lot of warmer than normal water, and there's been multiple reports of late of the oceans being warmer than normal and warmer than they've been seen maybe ever, but we don't want to go into that argument. But all we're saying is this heat, especially in this area, helps fuel the jet stream, helps fuel the storm track in the winter, helps produce storms, and therefore helps create surf. So this is good. We don't have cooler than normal water here, which has been the case the past 3 or 4 years. And so meteorologically speaking, everything's in play to help have a healthy storm track. I think what we just need is this inactive phase to sort of break down, get some more tropical warm moist air moving up into northern latitudes. That'll start goosing up the storm track, the jet stream. And even as it is right now, from when we looked at the jet stream track, it's not bad. It's not split. It's got a reasonable amount of energy pushing through it. It's just, for whatever reason, everything hasn't come together quite yet. Of course, it's still early in the season, too. Again, back to this chart, surface level ocean temperature anomalies, 1.5 degree anomalies here off in the East Pacific, a pocket there, a broad area of 1 degree anomalies, and just this one small area of 1.5 degree anomalies here. But again, the Nino 3.4 region, draw it right like that. Temperatures are definitely above normal. You can average it all out, but you're looking at about 3/4 of a degree, roughly speaking, which is good. And you can't complain about that. Now, of more interest, subsurface temperature anomalies, Kelvin waves. So we've been talking about westerly and easterly wind anomalies, and here's the scale here. The date line would be right here. This is the West Pacific. This is the East Pacific. We're looking at a profile on the equator looking down, 100 meters, 200 meters down, and we're looking at here's absolute water temperatures, and there's always warmer water in the West Pacific because trades blow west to east. But when the trades relax, or you actually get westerly anomalies, that is a relaxation of the trades, or actually westerly winds or a westerly wind burst, that takes some of this warm water, and you can actually see the ridge here in the thermocline. It starts pushing it to the east at depth, and that's exactly what we have here. Here's the channel. You can bound it just like that, and there's this like river that flows under the equator towards the Galapagos Island, and here 4 almost 5 degree centigrade anomalies south of, so Hawaii would be right about here, so about south of Hawaii on the equator, pushing east. So that's about a month and a half out from hitting the Galapagos. So now we're talking, and that'll erupt on the surface and then help feed the warm pool that we saw in the previous charts. The warm pool right on the equator, first gurgling up, say, around the Galapagos, and then working its way into the Nino 3.4 region, which would be right along roughly here. So one more Kelvin wave in flight. That'll take it probably 2 to 3 months. So we're into January before that warm water will get fully developed on the ocean surface here. And that's typically when El Nino peaks out, is the late December to, let's say, early January time frame. So one more Kelvin wave in flight. Easterly anomalies will shut down the creation of more Kelvin waves. Now, the point being, maybe this is these easterly anomalies and all that. We've had a good long run of westerly anomalies for a couple months here, and typically between Kelvin waves, you get what they call the upwelling phase, and we'll get a chart in a minute. And maybe that's just sort of the atmosphere taking a break before it goes into another run of westerly anomalies, but that's pure speculation on our part. Warm water at depth helps actually create sort of a little elevated bubble on the ocean surface if you strip out all the tides, all the swell, all the wind wave. And this is JSON-2 satellite data from November 9th, and they've stripped everything out, and they show clearly there is a 0 to 5 degree anomaly bubble pretty much from well west of the dateline almost to the Galapagos, with a core right here, about 5 degree anomalies here, and this is where the core of that Kelvin wave is, and 5 degrees centigrade is the above normal, is the peak temperature being measured right now in that Kelvin wave. So a very respectable Kelvin wave in flight. This sort of confirms it. And yet one more view of that Kelvin wave. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 4 to 5 degree anomalies. This modeled view suggests, but clearly no sign of an inactive phase or a cool pocket. If anything, it's just, and actually this suggests more warm water in the flow working its way down here. So that would be good news. Actually, going up to the other chart, it's not as pronounced on this one, but this one shows it as 1 to 2 degree anomalies. So that would be positive if one were to believe these charts. And finally, upper ocean heat anomalies. So you can go back in time. Here's one Kelvin wave that started last October or so. Couple degree anomalies. Here's the big one, January, February, March. Massive westerly wind burst set this Kelvin wave up. That erupted in the East Pacific in the April to late June-ish, July time frame. Notice the upwelling Kelvin waves in between. A little mini Kelvin wave in the August time frame erupting in late September or so, almost October. And now the next Kelvin wave in the series. Notice these are much weaker. This one was unprecedented in how large it was. It had everyone believing that some major El Nino was in play, but of course nothing has come to back that up since, and there's no evidence to suggest that any kind of a major El Nino event is going on. If anything, this is just a minimal weak El Nino, if even that. But still, more warm water in play. That's enough to fuel the jet stream, and the jet stream, as we said before, is looking quite good. So all is in play for a good, slightly better than normal winter storm season based on all the available data. So to quickly wrap it up, a rather anemic storm track is in play right now over the North Pacific. That's not to say there won't be surf. 13-second period swell, multiple events for both Hawaii and the U.S. West Coast, but nothing of any real size. El Nino-wise, things are still in play. Warm water is looking quite good across the equator. Nothing off the top. The jet stream's looking good. Everything suggests that the winter storm pattern should be a bit above average. Nothing over the top, but good enough. So, and there is swell in the water now, so go get some surf, have fun. We're going to do this again next week, same time, same channel. See you then. Thanks.